in my lab. I can think of 3 things that we've done that have kind of been, I think, you know, and I don't say it to credit myself because a lot of the credit goes to the students and postdocs who did this research. In many cases, they came up with these ideas, but one was the rediscovery of something called reconsolidation, which is when you retrieve a memory, it becomes unstable and new information can be incorporated into the memory at that point. It also means that when the memory is unstable, its restabilization process can be blocked, and if you block that, the memory is weakened or dampened. So that's how we've been using reconsolidation to help people with traumatic memories and try and dampen their memories of those traumatic situations. Not necessarily the conscious cognitive memories, but the emotional component of the memory. So that's one area that I think we've had a big impact in, and Kareem Nader really gets credit for triggering all of that research in my lab. Another area is a takeoff on that, which is a recent study that we published with Marie Monfil as the lead author, showing that we could take what's usually called exposure therapy, where it's also called extinction, where you condition a rat to be afraid of something, then you give the tone over and over again, and it stops being afraid. And this is also used in the treatment of phobias and other kinds of anxiety problems by weakening the fear associations that trigger the emotion. But the problem is that the fear always bounces back at some point, say by stress. So the patient has a fear of heights and then his or her mother dies, then the fear of heights comes back even though it was successfully treated. But we found a way in rats to prevent that bounce back of the fear. We can more or less permanently dampen it. And that has to do with a special procedure in which the extinction process is timed in a certain way. And it's too complicated to explain in detail, but simply by timing certain presentations of the stimuli, extinction can be made to be more permanent. And a third area, which is kind of a technical advance, Josh Johansson has recently published a study in my lab using optogenetics, which is a new way of altering brain activity. By what you do is you connect up a molecule that you're interested in with a virus so that it can be injected into the brain and alter genes in that brain area. And what we've been injecting are molecules that are light sensitive, so that you inject this virus into the brain, it puts a molecule in that part of the brain that then when you later implant a small fiber optic lamp in there, it's very tiny, it's just, you know, it's microscopic, but it goes right into the amygdala. And when you flash light on the amygdala, it causes the neurons in the amygdala to be responsive to light and to depolarize, so they have action potentials when the light shines on them. And what this allowed us to do is to test the basic idea that learning in the brain, or learning in this case in the amygdala, but in the brain in general, involves the depolarization of neurons, in other words, the firing of action potentials, while the neuron is getting a meaningless stimulus. So what we did is we presented the rat with the tone while we directly depolarized the lateral amygdala cells with the light. And this created learning in the form of behavior when the rats later heard the tone. So this is a very important technical advance, showing that a very basic principle of synaptic plasticity called Hebbian learning, after Donald Hebb, who said that learning involves the arrival of a weak synaptic input at a time when a strong synaptic input is activating the same cell. So in our case, the weak synaptic input is the tone, and the strong synaptic input is the direct depolarization of the cells. This depolarization obviously substitutes for the electric shock that we would normally give in a conditioning experiment. So those are, I think, 3 things that we've done that have been important. I don't know if they're the most important things in neuroscience, but I'm drawing a blank on that.